How to choose and use low E glass to shield radio frequencies. Design guidelines and strategies for reducing the EMFs from windows in new and remodel construction. My name is Michael Neuert. I have a bachelor's degree in engineering and I'm a licensed electrical contractor, and I've been doing this kind of work helping people reduce electromagnetic fields since 1992. And remind you, I am an engineer, not a medical doctor, not a licensed health professional. So any information here is based on my own experience, both from the literature and anecdotally with clients. But if you are looking for any kind of medical advice, please consult with a doctor. So today we're talking about one of the kinds of EMFs that's called the radio frequency fields. This is everything from like TV and radio broadcast towers, things that have been around for many years. Radar is a type of radio frequency. It includes the different antennas for emergency services and civic services. And of course, now these days, there's all kinds of antennas, microwave dishes, radio stations, TV stations, cell towers, all kinds of site-to-site communications. Of course, cell towers are some of what's more prominent now and getting closer and closer to where people live. And sometimes you don't even know when there's a cell tower nearby. In this case, this is a cell tower disguised as a large cactus. And of course, these are all cell towers. So something like this can be near your house or workplace and you don't even know that you have radio frequencies coming in fairly strongly. And of course, there's so many radio frequencies now, utility meters, the smart meters, even things like solar inverter systems mostly have wireless. And then of course, if you have a house like this and your neighbor's wireless devices, even if you have a very low EMF house inside where you've reduced your own devices, your neighbors around you, their Wi-Fi routers, their cable and phone gateways, TVs, stereo equipment, even the appliances now, refrigerators and appliances with wireless, and of course, Wi-Fi routers, cordless phone bases, and people using their cell phones outside the house, near your house. And adding to this, 5G is coming, which means more RF antennas near us, closer to us, and more RF frequencies as well. This is, of course, what's being called the Internet of Things, where everything is interactive and almost everything is electronic and talking back and forth to each other via radio frequencies. And the biggest thing, perhaps, with 5G is that it's coming to the streets. For a lot of people, the biggest exposure will be antennas like this on power poles, telephone poles, very nearby. These will be lower strength than the original cell towers, but because of their proximity so close to like this house here, they'll be relatively strong signals. Estimates are that maybe half of the cell phones will be 5G by around 2025, with probably full deployment approximately around 2030. Right now, in 2019, things are just getting started. So radio frequency exposures are increasing in strength and number. Almost every year there's more sources inside and outside. It's getting to be quite a lot of radio frequency sources, all adding up to a much larger radio frequency exposure than in previous years. So how do all these radio frequency fields from the outside actually get into your home? Like for this room, there's many ways the radio frequencies can get in here. One is over here on this wall. Say on the other side of the wall, this is an apartment, there's another neighbor there, and they could have a wireless router in their office right there, or a cordless phone at their bed, or using a cell phone. So it can come through a wall, or also say a neighbor's smart meter. All kinds of things that can come through the wall. Here we have a bathroom. There could be fields coming in from that direction from the house. There's going to be a window in that bathroom, and radio frequencies may be coming in through the window, through the doorway. That's another possibility. And you could have radio frequencies coming from below. If this was an apartment again, and there's an apartment below, sometimes that's quite a strong exposure coming up from below. And of course, you could have radio frequencies from above. You could have it coming through the roof, from cell towers, satellites. There is a lot of possibilities. Or again, if you have a neighbor above you, you could have radio frequencies coming in from the neighbor. And what about this wall here? You could be having radio frequencies coming in through this wall. Building materials tend to do some shielding, but not completely, so you get some shielding through the wall. But say there was a cell antenna tower just outside, maybe right there across the street or something, you could be getting a fair amount through this wall. But what about this window? So the windows in the house are the easiest entry for radio frequencies. If you have just plain old ordinary glass with no kind of low E coating or any other kind of metal in the glass, that glass is almost like nothing. It's almost like just having nothing there in the way of the radio frequencies. So for a lot of houses, the window glass is the main way that the radio frequencies enter the house. A lot of times 50% of it gets in that way, 75%, even more, because it's the easiest entry. And in a home like this, for instance, you've got all these great windows. If outside here you just have a natural area and some woods and no cell towers, there might not be very much coming in. But say there's a cell tower down there or a neighbor's house or a TV station tower, these windows are an easy entrance for that radio frequency to come in. So how can we shield windows like these? If you're looking at remodeling, or if you're looking at building a new house and you're concerned about the radio frequencies that are going to come in from the outside, not the radio frequencies from wireless generated inside, but things from the outside of the house, the majority of that will come through the windows if you do not take some steps to shield the windows. One possible answer is low E glass, what we call low E glass. And low E glass can be used to shield the windows from radio frequencies. Low E glass is a type of window glass with special low emissivity coatings. So the E stands for emissivity, which is the ability of a material to radiate and subsequently emit energy. Low E coatings are microscopically thin and thus relatively transparent metal coatings. So these low E coatings in windows, they minimize the amount of ultraviolet light, the UV, and infrared light, the IR, that can pass through the window, yet allow most of the visible light through that you want to come through. So these thin metal coatings are usually made of silver, and these coatings, as a result, can also reflect the radio frequency fields. So even though these windows are not designed for reflecting and shielding radio frequency fields, if there's silver in the coating, they do some shielding of the radio frequency fields. And why is there low E glass in the first place? Well, just for energy conservation purposes. If it's winter, like on the left here, and you've got the heat in the building, the infrared radiation from the heat source tends to hit the window, and instead of going outside, tends to be reflected back in, so you hold the heat in. And in the summer here on the right, it's exactly the opposite, where you have the infrared radiation of the sun coming in, and instead of going through the glass like the visible light, it gets reflected back off of the low E coating, so you do not heat up your interior space here near as much because of this low E glass in the window. So what is low E glass? There's different ways to make it, but basically you're looking at some kind of glass with a coating, sometimes several coatings, that includes at least one coating of silver. So in this middle example here, AG, that's the scientific abbreviation for silver. There's actually, in this e-glass, there's actually 3 silver layers. And if you look at the choices over here, this one company, for instance, they have a triple coat, 3 layers of silver, a double coat, 2 layers of silver, a single coat, 1 layer of silver, and you have different choices. So when you look at any manufacturer, there are different amounts of silver in the glass. And so basically what low E windows do is the infrared radiation, which is actually the kind of electromagnetic radiation that carries a lot of heat, like from the sun, because of that coating, it tends to come in here, hit the glass, and bounce off. And this visible light comes right through. And again, the UV light, that also, and depending on the coating, tends to bounce off the coating and stay on the outside. And what that also means is any of the indoor infrared radiation also tends to hit the glass and come back to the inside, so that you have this energy-saving characteristic. But now with low E windows, if we're looking at what happens with the radio frequencies, interestingly, say you have cell antennas and radio frequencies outside the house, with the low E glass, that also tends to get reflected outside again. And even things like the neighbor's wireless devices, those things that are coming in from the outside, those frequencies of radio frequencies tend to hit the glass and be reflected back out again. Not 100%, but a fairly good degree. So the more silver that there is in the low E coating, the more shielding, or the more reflection in this case, of the radio frequency fields. And here, if we look at this example from another manufacturer, and you look at these, how many silver layers they are, here we have elements 2, their product, there's 2 layers of silver. And then elements 3, there's 3 layers of silver. And elements 5, there's 5 layers of silver. So there'll be different products, some with more silver and thus more ability to reflect the radio frequency fields as well. When selecting a low E glass, ask the manufacturer which products have the most silver in the coatings, and that will generally tell you which are the most effective at shielding radio frequency fields. So now an interesting thing about this, though, is here. What if on the inside of the house someone is using a cell phone? Well, then that cell phone radio frequency field hits the glass and it tends to bounce back into the house. And for instance, in the same house, any other wireless devices like a Wi-Fi router, a wireless gateway, even wireless security equipment, things like that, those radio frequencies also tend to hit the low E glass and come back into the house. So the low E coating is like a two-way mirror. It reflects the radio frequency fields in both directions. That's really important to keep in mind for when we choose where do we want to install low E glass windows, or even if we want to install low E glass windows. So again, we want to pay attention to the outside radio frequency sources, such as cell towers, Wi-Fi devices of neighbors, versus the inside radio frequency sources, things like someone using a cell phone inside the house, the Wi-Fi router in the house, wireless gateways, all of those kind of things. So where should we install the low E glass windows? Should we install low E glass for all the windows, or just in certain rooms? Let's take an example of a layout of a home, in this case a one-story home, and where would it make sense to install low E glass windows? Let's take a look at some of the possibilities. One choice is to install low E glass for the children's bedroom. So we just have low E glass here, and we just do this one room. That's one choice. Maybe you just want to protect the radio frequencies that would have come in from the outside to keep them from coming into the child's bedroom. Or perhaps you want to make the choice to shield all the bedrooms. That's what some people do. Let's put low E glass for the master bedroom. Let's put low E glass for the children's bedroom so that all the bedrooms have low E glass. That's another choice, and that can make sense in some kind of cases. What about, sometimes it makes sense to put the low E glass on one side of the house. Like, let's say over here there were radio frequencies coming in from smart meters. Say there's neighbors' smart meters, that there were a lot of sources on this side of the house and they were coming right in. Well, then it might make sense to put the shielded E-glass on the entire side of all the windows on that side of the house. And if on this other side of the house there is almost no radio frequency coming in, very little, it's very minimal, then maybe not shielding these. Leave these unshielded with regular glass. And maybe for a house like this, it's exactly the opposite side that needs that. Say on this side, there's big cell towers, and they're making all kinds of radio frequency fields coming in from this direction, but there's very little in this direction. So in that case, it might make sense to put shielded windows on this side of the house, the low E glass windows. And you might choose not to do it on this side of the house, where perhaps there's less fields in this case. All depends on the situation. And then in some cases, and often this is the best case, especially if you're taking steps to not have wireless inside the house, then sometimes it makes sense to put the low E glass on all of the windows. And again, that often makes sense if you're minimizing the radio frequency sources inside the home, so there's very few devices inside the home, but you're worried about the radio frequencies coming in from the outside. Now, so as you can start to see, what we have to pay attention to here is that the radio frequencies can come in through the window. So if you have a regular glass window like this one, in this case, let's say no E-glass, but just a regular plain ordinary glass window, the RFs can come in, but the RFs can also go out that window. And in fact, if you have, say you have here a Wi-Fi router, and maybe over here someone's using a cordless laptop or device, and then these fields, some of these fields actually escape through that window. So sometimes you have sources on the inside and the radio frequencies are escaping via the window if it's not a shielded window. So here's what happens. What if there is more RF coming in through the window than going out? Well, then when you reflect that away with the low E glass, you'll have more of it going out and just a little bit of it coming back in. And as a result, you reduce the level in this room by using the low E glass. But what about this case? What if the radio frequency levels coming in, say from a nearby cell tower, are just about equal to the levels coming out, say from a nearby Wi-Fi router? Well, then it almost balances. And if you were to do a shielded window there, low E glass window, pretty much you have no effect on the resulting level of RF fields. You have almost the same as you had before. So here's a situation where you could actually put in a shielded window with the low E glass, and it has no effect on the radio frequencies in this room because the level that was going out before is now getting reflected back in, and it's about equal to what used to come into that room. And now, of course, here's the situation you want to avoid. What if there is more radio frequency going out than coming in? What if on the outside here, you just had some trees and a forest, and there's not much source over here, but in here you've got a Wi-Fi router and a wireless laptop, maybe a Wi-Fi refrigerator, you know, all the different kinds of things. You've got all these sources inside. Then if you have regular glass, some of these radio frequencies can escape more easily. And so if you have this situation where you have all the sources on the inside and you put in the low E glass, you can actually make this exposure to the living area increase because you're holding in the inside sources of the radio frequencies, and you don't have that much that was coming in from the outside. So it is really helpful to determine which source or direction of these radio frequencies is the strongest when you're kind of thinking about, do I want to put low E glass here or not? Do I want to shield this window or not? So a good idea, a good way to help figure this out is you can do a temporary mock-up and shield the window. If this is an existing building, not new construction, but if it's an existing building already there, you can do a temporary mock-up with aluminum foil and tape, and then use an RF test meter to see if the shielding the windows actually helps or not. So just ordinary aluminum foil, the regular stuff you'd have in your kitchen, it's cheap for a temporary mock-up, where all you do is you take a bunch of sheets of it, depending on the window size, tape it together, tape it up on the window, and do before and after tests with your test meter to see if shielding the window is helpful or not. So in other words, the aluminum foil test here, it's a very good approximation of how well that the low E glass will also shield. So rather than put in the window, the low E glass window, and then find out if it's helping you or not, you can actually do this little mock-up where you just take some cheap foil, tape it up over the existing windows, and then retest the radio frequencies again inside to see if you have made the levels lower inside, or maybe there's no effect. Or maybe you've actually made things worse. And besides aluminum foil, you can also use aluminum window screen, it's insect screen, because it's also cheap, but you can get bigger pieces. You can also tape that up over the existing window, and again, retest inside to see if the shielding the window as a concept is effective. And this aluminum window screen will shield similar to the aluminum screen, will shield similar to the low E coating of the low E glass. And then, of course, important with this is to have a good enough RF test meter to measure the radio frequencies before and after. There's different choices out there, and that's always changing. There's more things coming on the market, but be a little cautious of the really inexpensive, cheap ones, the one for, say, less than $150, where it measures everything. Those have such big quality issues that they may or may not be helpful for this kind of purpose. So how effective can low E glass be for shielding the radio frequency fields? How effective is it really? Let's take a look. Here's an actual situation, an actual client case. This was in a second floor dining room. It had these large windows. Actually, these had windows facing the street where there were smart meters and things from the neighborhood, other neighborhood sources. Not so much cell towers, but a little bit. And the main mitigation plan for them, for these radio frequencies, was to install the low E glass picture windows. And before the remodel, we had a level of 510 microwatts per meter squared. Now, in this particular case, over the 3 years of the remodel process, the levels in the neighborhood went up. I don't have the exact measurement of that, but after the shielding, where all we did for this room is have the low E glass windows installed. That's the only difference in this remodel. The level was down to 24 microwatts per meter squared, which gives us a shielding effectiveness of over 95%. Now, that is actually unusually good That's quite good for just putting in low E glass windows and not doing other shielding. Part of the reasons that we got such a good level, only 95.3% here, where we got such a good reduction level, is because this particular family was very careful. They absolutely eliminated all of their internal sources. So they had no sources inside the house, and they used a really high quality multi-layer silver low E glass. And then plus the other things, the way it worked out, which the existing walls had stucco on them, and they were already doing a fairly good shielding. So you can get in the 95% range with low E glass windows. Here's another example. This is the third floor family room of the same residence, and it has a large picture window facing the city below. So you can imagine now you're on a hill, you got these great views, but all of the TV towers and AM radio station towers and the cell towers, all these different signals, radio frequency signals, are coming right up through this big window. So originally, before the E-glass, they were getting a level of 6,400 microwatts per meter squared. Interestingly here, 3 years later, we actually found there was a 72% increase in the background level. So if we hadn't done the shielding, their level would have gone up in 3 years from 6,400 to 11,000 microwatts per meter squared. And when the room was shielded, in this case, again, just with the low E glass windows, the level came down to 160, which is quite good for this case, which is actually more than a 98% shielding effectiveness. So that's quite unusual. And again, this had to do with all the windows were shielded. And this particular room, actually all the windows in the house were shielded with the low E glass, not just this room, but so even the bathroom windows and their living room windows and the kitchen windows, they were all shielded with the low E glass. It's a major remodel. And so that stopped the entry into the house. And this particular room also had other rooms around it, so there was less external walls, and that's another reason why we got such a good reduction here in the radio frequencies. Again, I'm showing this to show you it's possible, but it is not typical. It's really, there's so many factors involved. It is in real life, it's actually generally difficult to achieve that good of a reduction. So what is a typical reduction? If all you do is put in low E glass windows for a room or for the entire house, typically for that room or for the entire house, for the radio frequencies, you're usually getting in the range of a 25% to a 75% reduction. That's a very typical kind of range. So 50% is normal, a little more, a little less is typical. But what's the possibility? Well, as we were looking at before, if there are a lot of sources inside the house, there's the possibility that you could actually make almost no reduction or actually make things worse. So we always want to be aware of that possibility when people use radio frequencies inside the house and they have the low E glass windows. Is this going to make it better or worse? Low E glass itself is quite good. Depending on the low E glass, just the glass now, not the whole room, but the glass, generally at least 95% and even up to 99.99%. And actually in most cases, you're above 99%. So the glass itself can be quite good, but the glass, there's reasons why it's not just the glass involved, because often there's a significant amount of radio frequency leakage through the window frame and the wall nearby the window. So the actual results vary greatly. Even if you have 99.99% glass, you sometimes get, there's gaps and there's places where some radio frequencies leak through around the glass. So for instance, in this room here, we could have perfect shielding of this right here of this glass, but you have one window here, one window here, and there's a little, and the framing here, there's a little bit of gap there. There can be a little bit of radio frequencies coming through here. Some comes through the walls between the windows. Some sometimes comes through the frame just on the outside. So Low E glass is not perfect. You can have these little gaps, and also how much even comes through the wall. The walls on each side here. There's a little bit that gets through there. So there are limitations to the actual reductions of the radio frequencies in the room. How will the new higher frequencies of 5G interact with the low E glass? This is a big question and a big concern. So 5G is coming. For instance, in this case, here's an example where you have here almost every utility pole has a micro cell tower, a little cell tower right on the pole. The existing 4G system is becoming saturated, and the industry needs more frequencies, more bandwidth. Everybody's screaming, wants more data. We need more data to flow. People are downloading their movies. Their smart cars are going to be coming that have, that are using non-driverless vehicles. There are all kinds of things that are happening where there's more and more demand. And we're not talking like in these next couple of years now, just like a doubling or a tripling or even a 10 times factor. We're talking about 100 times increase in the need for data transmission. So we're talking about 100, 200, 300 times more data in the next couple of years, in the next 10 years, and that's what the system is trying to do, and that's why 5G is coming. There will be more extensive use of the existing 4G radio frequencies. So with 5G, there's two things going on. One is they're going to use the existing frequencies we have right now much more often, lower power antennas near everybody's house, that kind of thing. And that's partly because these 4G radio frequencies are already some of the best frequencies for getting through and around walls, windows, doorways, and building materials. That's one of the reasons these frequencies are being used, is because they get into buildings so well compared to some of the other radio frequencies. And with 5G, there will also be new frequencies being opened up by, here in the US, the FCC, and in other countries, other organizations, for use by the telecom industry as well. These will be new higher frequencies above 6 gigahertz. So what we're talking about here is how will these new higher frequencies above 6 gigahertz, how will the low E glass coatings work for that? So adding new high frequencies in the range of 6 to 200 gigahertz, that's being done because those frequencies can carry more information. Not only do we need more frequencies, but we need frequencies that can hold more information. And the higher the frequency, the more information that you can transfer in that signal. But there's a problem. The higher frequencies do not travel as far or penetrate as easily through building materials or around obstacles as our current 4G frequencies. And that's probably because these frequencies, these new 5G frequencies, are getting closer to the infrared radiation and the visible light, those parts of the electromagnetic spectrum. And these kinds, infrared and visible light, as you know, they are more easily blocked even by weather events, like visible light and infrared, like when you feel the heat of the sun. Just by a cloud passing over the sun does a fair amount of blocking of these infrared and visible light frequencies. And as we get into these higher ends of the radio frequency spectrum, some of what 5G will be using, the physical properties, the physics of it is getting closer to that of like visible light, where it's actually more easily blocked. So as a result, these higher frequencies are more easily shielded as well. But the problem being here, there will be many more sources, more antennas coming from more directions. So even though it'll be a little easier to block, there's going to be a lot more fields coming in from a lot more directions. Now here's perhaps the most important thing, and the good news. Low E glass will provide relatively good shielding ability for the coming higher 5G frequencies. Those silver coatings, those solid silver coatings, not the mesh like the mesh in the window screen or the mesh in like a silver mesh fabric. That coating is a solid coating. Even though it's very thin, that will tend to do a fairly good job of shielding these new higher 5G frequencies that are coming. And then what about alternatives to low E glass for shielding windows? Is that always the right thing? One alternative is window film. So this is where you have a conductive shielding window film that you add to the existing window. So you have a window with regular glass. Instead of taking out the windows, putting in new windows with low E glass, you basically put this low E window film on there. This window film, again, typically will have some silver in it, and you get some radio frequency shielding characteristics out of that. You tend to have a little more moderate shielding effect for certain reasons we'll get into in a minute with the shielding effectiveness. You also, just like the other low E glass, these films do shield or reflect in both directions, so you have the same concerns. And some of the main limitations have to do with geometry. So you'll even look like at a window like this, like you see here, this low E window film only goes up to the edge of this glass. And then you have this frame, you have this whole frame area here that's not being shielded. Now low E glass tends to be installed a bit deeper, so you get some low E glass going further, and you have a smaller gap. When you have low E glass, when you use this window film, you have more gap, whether it's here, like something like that, or here at the edge of the window before the framed wall. So you have these limitations basically due to geometry when you use a film like this. It still works quite good, but not quite as good as a low E glass because of the geometry. Alternatives to low E glass for shielding the windows. In addition to the low E type of window film, another choice is shielded curtains. Window film and low E glass may not be as effective as curtain shields. And again, this is because like the window film only covers the glass and some RF gets through and around the window framing. What's good about curtains is curtains can extend beyond the frame. They can overlap onto the wall for better overall performance, for better shielding. For instance, in this case here, you can have in this case, a silver mesh fabric is going above the window frame and extending below, and on both sides on the wall is extending over to the wall. So you get an overlap of the wall, and you get better shielding geometry, which can give you better shielding performance, less leakage through the window. So here's an example. Here's a shielded room where we're doing a aluminum window screen on the floor. The walls are being painted with the Y shield paint, but we have the window here. Very important. What are we going to do with that? In this case, we're just painting. For this office, we do not really want to get into full construction where this window gets taken out and replaced with low E window glass. That's quite a big job. So in this case, the decision was to use a curtain shield, a fabric, in this case, high performance mesh that would go on this window. You don't see it here yet, it's not on here yet, but basically it would extend at least 6 inches on all sides of the window to do a good overlap of the window glass, and that's what we used. And we got quite good results from a level of 210 microwatts per meter squared with this shielding, including the window, down to 4 microwatts per meter squared. Here you can see, in this case, we're using the high performance silver mesh. On the left is a clear glass window. On the right is the silver mesh. Just like the low E glass, there's a little bit of affecting the view through the glass, but not too bad. So in this particular case of this doctor's office, where we had also added the low E glass here, where instead of doing the low E glass, we added the shielding curtains. And again, remember, curtains do the same thing. They reflect in both directions too. It's the same for all these radio frequency materials for shielding. It's almost the same thing. So in this case, with the addition of the curtains here, we got a 98% reduction in that room. And again, then this curtain did a great job because it went beyond the window glass to overlap the wall, so there's no gaps. And that was for both sides, top and the bottom. You get better shielding geometry when you're trying to shield the window with a shielded curtain like this. So why some people would choose not to use low E glass? First of all, low E glass, when you put it in, it's permanent. It's there. You can't remove it without doing major construction. And instead, some people will use the shielded curtains because they can be removed if you wish to do that later. Very simple to remove them. And here's another big reason that some people will choose, instead of putting in low E glass, which is permanent, they'll have a curtain because you could open those shielded curtains during the day. For example, for a children's bedroom and they're using their cell phone, and you want the cell phone signal to get out and not make the room higher for radio frequencies. Then during the day, you open the curtains and people use their wireless devices. And then you close those curtains at night. So at night, then, you put that shielding in place to protect people from the radio frequencies that are coming in from the outside during sleep. And hopefully you've turned off your own devices inside the room. And that's a common thing that people do when they don't, for instance, with children, and they don't want to, regulate like crazy the children not to use any wireless devices during the day. So they do this option where they have curtains that they open during the day, and then they close those at the night so their children are protected during sleep. And of course, there's a big one to avoid the disruption and the cost required to install new windows. If you want to install low E glass windows, that's a major cost. If you're already doing a remodel, it's one thing. If you have an existing construction, you do not need to replace the windows, except you want to do the shielding. That's another reason some people would do either the window film or the shielded curtains, because the cost to actually put in low E glass is significant in many cases. So for a quick review, number 1, low E glass can be used to shield the windows from radio frequency fields. Number 2, the low E coating is like a two-way mirror, so it reflects the radio frequency fields in both directions, something to keep in mind. Number 3, the more silver there is in the low E coating, the more shielding or reflection of the radio frequencies that will be achieved. Number 4, when selecting a low E glass, ask the manufacturer which products have the most silver. Those will be the ones that are the best for reflecting radio frequency fields. Pound sign number 5. Low E glass will provide relatively good shielding ability for the coming higher 5G frequencies. So the nice thing about low E glass, it's already going to be a good material for what's coming up, where some of the mesh materials might not work as well with the new high 5G frequencies because of those little openings in the mesh materials. Some of the higher end of the 5G frequency spectrum will get through some of these mesh fabrics where they'll be stopped quite well from the low E glass. Thank you for joining us. For more information on EMF training videos and courses, please contact us, info@emfcenter.com, or our website is emfcenter.com.